Hi everyone, and welcome to the final session of the day, 4 o'clock. I will try and make this not drag on for too long, because I'm sure everybody wants to go to the get some swag and whatever is happening after this. But there's a lot to it. There's a lot to cover today, so some of it I won't go into much detail on. I'm going to try and do a live demo if the facility Wi-Fi allows me to. The title of the session is Building a Private DevOps Platform on VCF, which is a huge topic. This sort of thing could be done in a lot of different ways, but primarily what I'll be looking at is creating a sort of cloud-like consumption interface on top of VCF using the new name vSphere Supervisor and VKS, which I will be trying my best to refer to it as VKS today. This is the new name for what used to be TKG. So we'll go into a little bit more detail about what that is, but just a bit of an agenda. We'll start off with an introduction. I'll talk about the sort of building blocks required to create this platform. So what's included in VCF to help you build out that DevOps environment. This primarily is the supervisor, so we'll look at what that is, a few slides on that, and then we'll go into a demo where we will look at an actual VCF environment that is being configured with this supervisor. We'll look at it from the admin perspective and the developer perspective. So we will, as a developer, we will deploy an application to our VCF private cloud, and we will deploy that application onto VKS, vSphere Kubernetes service, or as you might know it as TKG. Bit of an introduction. My name's Adam Truebridge. I'm an SE at VMware or Broadcom, and I guess we'll get into it. So when we talk about a cloud model in this context, there's two personas that we primarily look at. These two personas have sort of differing needs and requirements out of a platform. You've got the consumers on the left, who would sort of be your developers, your engineers, utilizing the platform, building their applications. And then on the right, you've got the infrastructure admins who are creating and managing the platform day to day. The developers are interested, well, they want to be able to use this platform in the way that they're used to. So they want to be able to use the API that they're familiar with. They want to use infrastructure as code and other DevOps concepts that they're familiar with. And they want this to be delivered in a self-service manner. So they don't want anybody to get in the way of the process that they go through to deploy their applications. Admins, on the other hand, want to make sure that this is compliant. So if they're running this day to day, they want to ensure governance, they want to be able to apply policies to the environment and keep track of costs and make sure that the infrastructure is being utilized in an efficient way. So I'm going to sort of have two hats in this presentation today. I'm going to be looking at some of it from the consumer, from the developer perspective, and then some of it from the infrastructure admin side. So what do we need to build up this cloud interface? Well, at the bottom of it all, you need virtual infrastructure. So you need a compute platform to run your applications on. This, of course, is something that as VMware we're very familiar with. You know, we've been building vSphere for 25 plus years. So the virtual infrastructure there we have already. It is solid, and I guess in most cases that will be VCF. We need a supervisor on top of it to create the declarative API that our developers use. So this is provided as the vSphere supervisor in VCF, and that provides a selection of core services that allow the developers to interface with the underlying infrastructure using code. We then offer a selection of supervisor services on top of this that sort of add additional functionality to that supervisor. For example, image registries for containers and various network constructs that our developers can use. The admin can then sit on top of that and introduce guardrails around the environment, policies and quotas for resource consumption, that sort of thing. And then, of course, we want to provide an interface for our developer to use. We can provide a choice of interface. The developer can use the tooling that they are familiar with on our platform. So if we have a look in a little bit more detail about these, bringing in the two different personas. If we start off with a sort of a fresh VCF environment, which we'll come to it in the demo, our VI admin has configured that VCF platform to suit their business requirements, and they've gone in and they've enabled the vSphere supervisor on top of that. This has created a few different services. So the VM service to allow our developers to go in and declaratively create VMs, the VKS Kubernetes service, which we'll focus on today, the network service and the storage service to help them consume those resources out of VCF. The consumer can then, of course, deploy their services on top of that. The admin can then configure those additional supervisor services. So we bundle a handful of these into the supervisor. For example, Contour for application ingress. Harbor is our image registry that Joe talked about a little bit this morning. External DNS and Data Services Manager as examples of some of those supervisor services that the admin can easily deploy to add immediate functionality. There's then a selection of different constructs, and we won't go into all of these today, but you'll see some of these in action in the demo. Constructs such as vSphere namespaces for separating our developer environments apart, and then providing them with quotas and access policies around those namespaces. So this is where our admin can come in and introduce the governance on the platform. They can then enable the sort of pathways for interfacing with the platform, how the admin wishes, and then the consumer can use those interfaces to deploy their applications. This is a bit of a visual representation of what the infrastructure will look like once we've taken our VCF environment and added the supervisor on top to create the platform. From the bottom up, you've got your VCF environment, so you've got some sort of compute, storage, and networking, likely vSphere, vSAN, and NSX. We've wrapped a supervisor around it, which I'll come to more detail on the next slide. This is what's provided that control plane API upwards for our developers to use. And we've got now these modern applications running on our supervisor side by side with sort of your traditional virtual machines that you have already deployed in vCenter. So we've got these different application types all running side by side on that same VCF infrastructure. You can see here we've got vSphere namespaces, which is what are providing those sort of envelopes of resources that we can then deploy our applications on top of. You could deploy virtual machines declaratively onto a vSphere namespace. You could deploy Kubernetes pods directly on top of ESXi hosts in those namespaces, or you could deploy an entire Kubernetes cluster to run your application in, which is what we're going to do in the demo in a second. So I keep referring to this supervisor, which can be quite a sort of a new concept within vSphere. So I'll go into a little bit more detail about what that means. But essentially, this is the layer that's providing that API on top of our VCF private cloud. So, if you're familiar with the construction of a Kubernetes cluster, a Kubernetes cluster has two ingredients. One is a control plane, so that could be a couple of nodes providing that orchestration, and then worker nodes or a node pool that actually runs the applications in the cluster. And when we enable the supervisor, what we're really doing is converting that vSphere cluster into a Kubernetes cluster. So we're taking the ESXi hosts, the bare metal hosts underneath, and we're converting those into worker nodes for a Kubernetes cluster. And then we're deploying 3 virtual machines on top of that, called the supervisor control plane, which act as that Kubernetes control plane for our cluster. These then come in and allow the consumer or the developer to use a standard kubectl API to interface with our supervisor and then deploy Kubernetes-based workloads directly to those ESXi hosts. That then gives us the concept of a vSphere namespace, which is essentially it's similar to a resource pool in vSphere. In fact, part of the construction under the hood is a resource pool where we're able to create envelopes for our developers to deploy resources into, separate those at the network level, and apply quotas and policies to them. Our developers can then create virtual machines and Kubernetes clusters within those namespaces. Something to call out, I guess, is remembering the difference between a vSphere namespace and a Kubernetes namespace, because a vSphere namespace exists only in the construct of vSphere. So we, as an admin, are creating those vSphere namespaces on top of VCF, and that's where we're separating the developer environments. They can then log into one of these vSphere namespaces and create their own Kubernetes environment with Kubernetes namespaces, but those are two sort of separate concepts. vSphere namespaces exist at the vSphere or the VCF level. And this is all for providing isolation between those environments. So whether we want to split up those namespaces into prod, dev, staging, or if we want to allocate a namespace to separate projects, however we want to carve that up, vSphere namespaces is the construct that allows us to do that separation. That's it for slides at the moment. What I'm going to do is dive into an actual lab and show you what the supervisor looks like within vSphere, and we will create a namespace which later on in the session we'll deploy an application to. So,
could I clarify something very quickly?
Yeah, of course.
So I think on one of the slides you said that the ESXi host becomes a worker node.
Mm-hmm.
Doesn't it just host VMs that are worker nodes?
So there's two different ways that you could use that as a worker node. So when you initially enable the supervisor, we are converting that ESXi host into a form of worker node itself. So there's a process called spherelet that would be placed onto that ESXi host to allow it to essentially become a Kubernetes worker node. We're not running the Kubernetes pods themselves in the ESXi kernel. They have a further layer of, a very small layer of virtualization around them, but you can use them as worker nodes. So you can deploy, they're called vSphere pods, directly to a host. Or you go a level above that, which we'll be doing today, where you deploy, it's called a guest cluster, where you add an entire Kubernetes cluster on top of vSphere, which would be a fully sort of upstream compliant Kubernetes cluster on top of vSphere, which is, like you say, where you're virtualizing the worker nodes in their own VMs. essentially. But we'll see what that looks like in the demo.
So the answer, it sort of does some stuff to it that sort of makes it like a workload, but it's not.
Yeah, so you could use it. We can deploy pods to an ESXi host directly without having a worker node in a virtual machine above it.
Yeah.
But I guess it is possible.
It's both.
Yeah, it's both.
It is a worker node. The ESX is a worker node, but we're going to deploy workloads on top
Yeah.
of it as well.
I guess the reason.
Runtime as well, so it's a CRX specific runtime, not just standard.
Yeah, yeah. Which is why if you want an upstream aligned Kubernetes cluster, then you would deploy the worker nodes as virtual machines on top of vSphere.
I think that the reason I asked about it is if you say to a Kubernetes engineer the ESXi host is a worker node, that would mean a specific thing to them.
Yeah.
If that makes sense, which it's not. But you're saying it is a bit, but it's.
I think I'm just trying to, if he doesn't illustrate that, then someone can challenge and say, like, so what was it, there's Kubernetes in ESX, and then we put Kubernetes
Yeah.
in ESX, which is where it's about to go just now, and the one that's going on is fully upstream conforming Kubernetes. But the fact of the matter is, you could run pods on the host. It is a capability
Yeah.
that's there.
Yeah. Okay.
So it's both. Like it is a worker node. I'm going to put worker nodes on top of
Yeah.
it, and there is logic and rationale for why you would use one
Mm.
over the other.
Yeah, exactly. Thanks, Chris. So it looks like I do have access to the demo environment, which is great. What we have here is essentially a vanilla VCF environment. So we're running simply vSphere, vSAN, and an NSX. Nothing else. No virtual machines are deployed. We're just using this for VKS. What happens when we deploy the supervisor is we get a new resource pool created in vCenter for us called namespaces, which is where those vSphere namespaces will appear. So there are a few already created. I have some supervisor services already deployed. So you can see, for example, Harbor is running here as my image registry, and I have a few custom namespaces which I've added in case a demo goes wrong later on. And you can see underneath here are 3 supervisor control plane VMs which come together to create that control plane and our API access. The namespaces are configured in the workload management page on vSphere. So here we can configure supervisors, we can create supervisor services, and manage the namespaces for our developers. So what I'll do is create a new namespace for this demo today. We'll select the demo supervisor that I've already deployed into this environment. We'll give it a name, so something like Hello VMUG, and we will create that namespace. From here, this is where, as an admin, I would configure those guardrails and permissions for my developer to utilize this namespace. So, for example, I can use the identity providers which are already integrated into vSphere. I don't have any Active Directory configured in this environment, but I have some developer accounts in my vCenter already that I will give access into this environment. Storage for VKS is done through storage policies, so exactly the same way as you'd be applying policies to your virtual machines. You can apply those exact same policies to Kubernetes objects within the supervisor. So if I click Add Storage, I only have 2 policies in this environment. You probably have a lot more configured for different tiers of storage. And in here, you would allow the developers to consume the policies that you want them to be able to. So if you had different policies for different failure levels, then you could make those available to the developer in here. I'll just have this Kate's storage policy here, which I will make available for my application. The final thing to do is to configure the VM service. So The VM service in the supervisor allows me to define virtual machines in a declarative way as a Kubernetes object and apply those to vSphere using a sort of a YAML configuration. And part of that is translating what I want the desired state of my VM to be to items in a content library. So if I want to be allowing my developer to deploy Windows images, Linux images out of my content library in their Kubernetes world, then the VM service is where I would allocate those templates. So I'm going to give my developer access to a couple of virtual machine classes, which are similar to, well, they're similar to the classes that you would get in ARIA automation. They're essentially t-shirt sizes, which I've defined for my virtual machines. So I'll give small, medium, and large as options. These have some pre-configured CPU and memory reservations, and here I can pass PCI Express devices, for example, into my Kubernetes cluster. And there we have, from the admin's point of view now, my namespace is configured, I've set some guardrails, I've allocated some resources. It's now up to the developer to utilize this namespace to deploy their applications. So I'll hop into, I'll take my admin hat off and put my developer hat on and have a look at, from their point of view, what they now have access to in their interface of choice, which as a developer might be the commands line. So if I copy my login command, so I'm using, so the kubectl is a fairly standard API for accessing a Kubernetes cluster. We have a vSphere plugin for this API, which allows developers to interface directly with that supervisor. So I'll log in with my vSphere credentials, and hopefully what we can see here is my namespace that I just created, Hello VMUG, is available as a context within Kubernetes. So I can now use this as essentially as a Kubernetes namespace. So if I hop into my Hello VMUG, if I can spell, and have a look at what's running underneath the hood. So where we were talking about the ESXi cluster being configured as worker nodes, if I run a get nodes command to look at my Kubernetes cluster, you can see I have 3 control plane nodes, which are those supervisor control plane VMs that have been created, and you can see my ESXi hosts in here configured as worker nodes. In this case, it's just a single node cluster, so you would have more worker nodes in there, most likely. And that's it, really, because the developer can now just start to deploy Kubernetes resources to this namespace. If you tried to deploy a Kubernetes manifest for a sort of a pod-based using containers, then those would deploy as vSphere pods directly to the ESXi hosts, but we want to go that level above and deploy an entire Kubernetes cluster on top of this. But what I'll do first is just talk a little bit about what that Kubernetes cluster on top will look like. So the Kubernetes service that's included in vSphere, in the supervisor, is, as we said, now called VKS, vSphere Kubernetes Service, previously known as TKG. And this is that upstream aligned Kubernetes flavor that you're able to deploy straight on top of a vSphere cluster. This is done through what we call the cluster API. So this is where you're able to create a Kubernetes manifest, a Kubernetes object that represents the cluster that you want to deploy to your infrastructure. So this will be a construct that the developers will be familiar with. This is how they would define their applications. If they're deploying a load balancer, they will have a manifest for that load balancer. And what we're essentially doing with the cluster API is allowing that same concept, but to define and manage the lifecycle of a Kubernetes cluster using Kubernetes. So here could be an example of one of those cluster manifests. So you can see we're allocating it to a namespace. We can choose a Kubernetes version in this manifest that we'd like to use, and this is where we're bringing those virtual machine classes in that I gave the developer access to. We're using that VM class to define the size and shape of the nodes within our cluster. We're also able to use that storage policy that we pulled out of vSAN to sort of tell Kubernetes where to point the storage for those worker nodes to. We'll hop back into the lab and we'll deploy a cluster. So I've created a pretty basic manifest description of a cluster that I want to deploy. The application that I'm going to be putting on top of this cluster is called Yelb, which is a common application that we use to demo Kubernetes. So I've named my cluster VKS Yelb cluster. We want to deploy that to our new Hello VMUG namespace. I've left most of the networking default. These manifests can be as complex as they need to be, or as simple as you want them to be. I've selected a version of Kubernetes that I want to use, and I'm using those virtual machine classes that I gave the developer access to within that vSphere namespace. So best effort medium, and I'm using that storage class that I created. Fairly simple cluster with one single control plane and one worker node, so it's fairly small. If I pull my terminal back up, that cluster is represented in a YAML file in a directory on my machine, and I can go in and apply that manifest to my cluster in the way that I would apply any other application or Kubernetes manifest to any other Kubernetes cluster. So if I apply that, you see that cluster is being created. So what I'll do is, so it's creating that cluster in the background, and if we hop back into the vSphere UI, you can start to see some things being done in the background, in the logs. It's deploying virtual machines, it's creating resource pools. So what that's doing in the inventory, if we look back to our namespaces folder that was created, when I made that vSphere namespace, it created a resource pool within the vSphere UI called Hello VMUG. If I expand that, it has some resources underneath that I'm deploying. You see a new Kubernetes resource has been created in the UI called VKS Yelb cluster, so the name that I selected for that cluster. And then underneath that, some OVA files are being deployed automatically by the supervisor to build out that cluster. If we look at one that I've already created, so a namespace called pre-deployed, you can see there those two virtual machines have been created that build out my Kubernetes cluster. So you can see they're tagged developer managed because the lifecycle of that VM is being managed by the supervisor. So now that I've got a cluster, what I'll do is I'll hop into that cluster that I pre-deployed so that we can look at what that looks like from a Kubernetes perspective. So I'll log out of the supervisor, and we'll run a slightly different command to log into that cluster that I've pre-deployed. So pre-deployed, log into that, and now if I get the namespaces that are available to me, it should be blank. So these are just the default namespaces that are created on a blank Kubernetes cluster, and this is now that upstream compliant cluster that we can deploy our applications to. So if we look at the nodes that are building up this cluster, it's those two that we defined in that manifest, that one control plane and the single Kubernetes worker node. I want to deploy an application to this now. So what I'll do is my developer would create a namespace for their application. So I'll create a namespace called Yelb, and I will apply the manifest for my application into that. Well, first I'll give myself some permissions, and then I'll be able to deploy that application. So this is just, this manifest for this application is being stored on GitHub, courtesy of William Lamb. So anybody can deploy this application at home to test this out. So as you can see, that application has deployed a few resources into Kubernetes. So there'll be a handful of pods, a database, and a load balancer created. So if we just look at what that looks like in Kubernetes, you can see that those pods are being deployed within my cluster. One container is still being created for the app server. We have some Kubernetes services and a load balancer. So hopefully this IP address will give us access to that application that we've just deployed, and we can have something working. Which, when it loads, we do. So it's just a simple application with a database running in the back end, and it's persistent to my session. So we have essentially a full stack application deployed using Kubernetes on top of that upstream compliant Kubernetes cluster, which we've deployed declaratively through the cluster API on top of our VCF environment using the vSphere supervisor. That is, I've just been told that I'm almost out of time. So we've done the cluster and we've deployed an application. Thank you for your time today. Are there any questions while we're still going? It was a very quick run through. I know there's a lot to take in on the Kubernetes side, but if there's any questions you have and you want to come back to me afterwards, then you're more than welcome, or take them now. Yeah?
I was just curious, have you seen many deployments leveraging vSphere pods?
vSphere pods. So depends what you mean by deployments. They're commonly used because they're used for supervisor services. I haven't seen many or any deployments of a production application to vSphere pods. I don't think that's common. I'm not sure that it's recommended. I don't have a strong answer to that, but they're certainly used because when you deploy a supervisor service, so I mean, for example, I'm running Harbor in this lab. That supervisor service is being deployed with vSphere pods. So you can see the components that make up Harbor, for example, its database, is running as a vSphere pod and being managed. So you can see that icon there represents a vSphere pod within the supervisor. So that is being run on the host itself rather than in a guest cluster like we've just done. But I haven't seen any instance of it being used for sort of a production application. Anything else? Yeah.
Quick thing, if you've got an existing cluster that you want to test this out, as it were, can you mix and match existing ESXi workloads and have this layered on top?
Yeah.
Does that not work? Okay.
Yeah, no, that's exactly what this is trying to do, where you have those existing virtual machines running side by side with containers and modern infrastructure. So it just happens that in this lab, I don't have any workloads running on VMs. I mean, I've got a Windows VM running, but that's about it. But there's no reason why you can't go in, configure the supervisor, and start deploying resources in a cluster if you've got a dev cluster and want to have a play around with it. As long as you've got the load balancing facilities there for it, then you can configure the supervisor and start playing around with it. Cool. Thank you, everyone. And I think there's probably stuff going on upstairs now for the next half an hour.